performing linear regressions. I love linear regressions. So we're going to turn our calculators on. And the first thing we're going to do is we're actually going to clear the memory of anything that's in here. You know how to clear memory on a calculator? Okay. If you look above the plus sign, you're going to see that it says mem for memory. So you do second because it's in blue. Second in the plus sign. Memory, we want to do number 7. We want to reset our calculators. 7. All RAM, number 1, enter. And then number 2, reset. All right, so it's been reset back to the original configuration. We have some data here, and we're going to enter this data into our chart. And you always need to have X and Y. I mean, you're on the Cartesian plane. You always have to have an X and a Y. The biggest mistake that students make when dates are given is that this is 0 for X. This is 1, 2, 3, 4, 5. First of all, I should have checked to make sure my dates were consecutive. 97, 98, 99, 2000, 2001, 2002. So make sure they're consecutive and then label them 0 up to 5. If I had a missing date, I would still have to have a number for it. So 2 mistakes, students don't look to see if the dates are consecutive. Second mistake would be not starting with 0. They think they start with the number 1. We're going to go to statistics, stats. And we are going to edit a list, number 1. And now we can start entering our data. So the first number for X is 0, and then you say enter. 1, enter, 2, enter, 3, enter, all the way up to 5. All right, now arrow over to the second list, and we're going to enter in that data for next to where it says year. You should put this as X, X years, Y sales. And now we're going to enter in our Y values, 27.9, enter. The second step says that we need to choose a plot setting. Press second, Y equals, and if you look above this one in blue, it's stat plot. So we hit second, above Y equals, and that puts us into the stat plot. We're always going to be going into the first one. Enter to get into the first one. And right now it's on the black. It's off, so I want it to be blinking on the on. Now it's been on. What kind of plot are we doing here? The first one, it's set for us. We're going to go down. It says list 1 and list 2. That's good because that's where we have our data. And now what kind of mark do you want to have for your scatter plot? I like to have the open boxes because it just shows up better. So I'm going to hit enter, and we're done in this page. So we can quit. Step 3 says now we're going to make a scatter plot of our data. What is our data going to look like? So what does it say to do? It says to go press zoom 9. Here's zoom. So we're going to press zoom. And these are all the different ones you can zoom in. You can zoom out. You can do a standard 10 by 10. That's what the standard means. It's a 10 by 10 grid. But it says to do number 9. Zoom stat. It's going to zoom right in our stat. Exactly, because it's going to be anywhere in time and space. That data is so spread out sometimes, it's not actually in your screen. So when you do zoom stat number 9, it focuses right in on your data. So there's my data that we punched in. The next part would be, we see the data here, but we want to create a line. We want to create a linear function that best describes this, because if I have a line that goes pretty close through all that data, I can predict in the future. That's why we like regressions, because you can predict a little bit out. You can't go too far because times change really fast and that data changes. But within the next week, month, you'd be able to predict some things. So the next part that we're going to go to is finding the best fit line. You're going to have to do this every time when you do regressions. You put your data in, you get the zoom stat graph on your calculator, and then you're going to write an equation of a line. So this is right, so press stat. Then what does it say to do? Press stat from the calc menu. Where does it say calc menu on here? Right here, right? Right at the top? So you actually have 3 sections on the screen right here. Right now we're under the edit section. Calc means it's going to calculate something for you. So if I go over It's going to calculate stuff for you. And then test, again, you're not going to have to worry about that in here. That's statistics. So up at the top, you go to calc. And then what does it say to do? It says, from the calc menu, choose line reg AX plus B. Look to see where line regression AX plus B is. Use your arrow keys. Line, oh, there it is, number 4. That says linear regression. How about MX plus B? Does that sound familiar? Right, that's a line. Here they're using A instead of the M. So A is your slope, B is your y-intercept. All right, we're going to hit enter. X1 is list 1. Y is list 2. You don't have to worry about frequency, so I'm going to go down. I think it would be too much today to show you how to get the calculator to put that equation in for you to graph. I think it would be too much for you today. So we're going to skip this part right here. We're going to hit enter. We're going to calculate, and then we're going to write down our data. And it actually says it right here. Look on your calculator. So mine doesn't say R. Yours probably doesn't say R either, does it? Okay, good. Here we go. Quit. We need to go turn something on. We need to turn the diagnostic on. So quit out of there. You do second, and it's above mode. Yep, anything that's written in blue, you have to use that second button. What do you think the alpha button's for? Take a look at your calculator. If the blue second is for anything written in blue, for anything that's right. So you have green letters here. You have things that are in green, so you'd have to use the alpha button for anything that's written in green. It's in blue, so we're going to use second, and we're going to open the catalog. And here is everything listed in alphabetical order. So I'm looking for D for diagnostic, so I'm just going to hold it down until I start getting into the D's and let off. When I get into D's, I'm looking for DI, diagnostic. There we go, diagnostic off and on. We need to turn it on. So the little arrow is next to diagnostic on. And then you hit enter. And hit enter again. And done. All right, now our calculator will look like this. So we'll have R and R squared. So we're gonna go back to finding the linear regression. So stats. We would like to calculate at the top, calculate, and down to number 4. I can just press 4. 4. And here we are. So we have X, we have list 1, enter, list 2, enter is good, enter, enter all the way down to calculate, enter again. And now our calculator looks like the one that's in our book. So what we see here is that it tells us y equals ax plus b. What does a represent again? Well, if we look at the formula, y equals ax plus b, what's a represent in the formula? Slope. And what's b represent? Very good. So a is our slope, b is the y-intercept. So our slope is 1.36. I would use 2 decimal places. So we have that a equals, where can we put this? A equals 1.36. And above that, I'm going to put y equals ax plus b. And then we know we need b because we need the slope and the intercept so we can graph. And I would say that b is 27.72. And I'm going to be able to go and graph the line now. So now that I have my slope, I also should be writing down what R is. R is about the correlation coefficient, and that was from step 4. So for step 4, describe the correlation. Well, correlation is about R. So you might want to underline correlation and put R. We see that R was 0.98. I'm just going to put 0.988. I went to calculate a linear regression, and it gave me all the data that I need to finish this problem and answer questions. I am going to I'm going to quit out of here. It's important that you write down your information. Otherwise, you'll have to go through those steps again to get this. So every time you get to this page, write down A, B, and R. Okay, quit. Y equals, and there it is. Y, I can graph as many equations in there as I want, but I want to graph y equals ax plus b. So before we finish, let's make our equation. Y equals 1.36x plus 27.72. Graph. And we have y equals 1.36 Here's your variable button. 1.36x plus 27.72. And then we're going to hit graph. Graph. There's the best fit line through that data. All right, so let's talk about the data that we actually have here. What does it mean to be a correlation coefficient? From the picture, it means how close your data is to that line. How far away is it? How close is it? So we have one that's a little bit away, and the rest of them are pretty close to it. That's what the correlation coefficient is about. How closely is the line a best fit line for the data? If you look at the top over here, it's going to give you some numbers so that you can tell just by looking at numbers. The correlation coefficient R close to 1, it has a strong positive correlation. So when R is close to positive 1, that means that you have a strong positive correlation. And and then when R is close to negative 1, that means that you have a strong negative correlation. So the closer you are to 1 or negative 1, you're going to have a strong positive or negative correlation. When isn't it going to be a strong correlation? What does a strong negative look like? The line is going down. That's why it's a negative. What's a strong positive? The line's going up and it's fitting very close to the data. So when it's approaching 0, that means the data is moving away, and it's not a very good fit. You shouldn't be making any predictions on something that's not closely relating the data. So that means that for R close to 0, the data has relatively no correlation. And if we actually look at our R, we had 0.988. That's really that's almost 1, right? The 8's going to round the 9 up to a 1, so it's very close to 1. That's how correlation works. If you don't have it close to 1 or negative 1, it's fine to be close to negative 1. If it's at 0, can't make any predictions about it. It's no good. That's it. That's linear regressions in a nutshell. Now we just have to practice using your calculator and being able to get the data in there and get the linear regression. Here we go. We got another example to do. So we're starting all over. You go to stats. And then number 1 is you're editing your list. So I hit enter on 1. I want to clear those lists because I don't need them anymore. So I just go up to the top on list 1, hit clear, and come back down. I go over to list 2. I use my arrow keys and go up. I hit clear, and then I come back down. I need to check my years to make sure because I'm going to give you some that are not consecutive years, and then your whole data is going to be off. Sure. We have 97, 98, 99, 2000, 2001, 2002. So all my data is in order, and I like to write down that this is 0, 1, 2. In the beginning when I'm doing this, I won't always do this, but just to remind myself to start on 0. And then the last thing would be to say, okay, years is going to be X, and sales is going to be Y. I'm ready to start entering my data. So what I want you to do right now is I want you to look back on here and try to get started. I'm going to go through it with you, but try to see if you can start entering your data and start. How far can you get in your notes so that you can do your homework? When I went to Zoom Stat 9, this is what I got. It says dimension mismatch. That means when I go back to stats, go back to stats, look at my list, notice that one of my numbers is not punched in. I have 5, but I don't have any data next to it. That's a common mistake that I've seen from students, punching in too fast. So if you get that error message, go back to your list and check your list, okay? So if you look down right below this, it says number 2, find the equation of the best fit line. That's where you're going to write your equation. Y equals negative 0.0 X, and then B is positive, so plus 10.48. And then I'm looking for something that says correlation. On 1, it says describe the correlation, so I'm going to put R equals negative 0.26. So let's talk about, make sure that you're using this negative sign down here when you're graphing, right? This is the negative. If it was in between it, if it was 4 minus 5, obviously I'd use the minus button, but it's coming first, so negative 0.05x plus 10.48 graph. On number 1, it says describe the correlation. What do you think? Based on your R, what would you say the correlation is? Based on what the picture looks like, what do you think? Does that data closely fit the line? It doesn't. Relatively no correlation, because 0.2 is pretty close to 0. It says, how could you use the best fit line to predict future sales of men's clothing? How could you predict future sales of men's clothing? What do we know about a correlation, relatively no correlation? Can you really even predict that? So you wouldn't be able to predict anything based on the correlation. So that's your answer for that one. It doesn't have a strong correlation. It's hard to say if it's going to go up or down, but nice try. Based on relatively no correlation, you can't predict the future, something like that. You can't make a prediction. And it says explain. Well, R equals negative 0.26. That's my explaining. Relatively no correlation. Now you know how to do linear regression. So let's go and practice some more. Looking at the next set of data, I'm going to go to y equals. I'm going to clear the line that's in there. I'm going to go to stats. I'm going to clear out my data. The table shows the number in millions of music album downloads and the number in millions of individual federal income tax returns filed electronically each year from 2004 to 2008. Analyze the data in terms of correlation and causation. I see X and Y. So if they're calling those X and Y, then I'm thinking that that's my data and I'm not actually using the years this time.